Welcome back to the AI cost optimization series. In the last episode, we learned how to reduce input token costs by summarizing old conversation history instead of sending every message again. But conversation history isn't the only thing increasing your costs. What if your prompts are longer than they need to be? Long instructions, repeated context, and unnecessary details can all add extra tokens and extra cost. In this episode, we'll learn a simple technique called prompt compression and see how to make prompts smaller while keeping the same meaning. This is AI cost optimization, layer 2, input layer, technique 3. Let's look at a real system prompt. Many of you write prompts like this. Please carefully analyze the following customer review and provide a detailed sentiment classification indicating whether the sentiment expressed by the customer is positive, negative, or neutral, and explain your reasoning in a thorough manner. That's 48 words. Now watch this. Classify sentiment positive slash negative slash neutral and give a brief reason. That's 10 words. Same instruction. 80% fewer tokens on every single request.
Now remember our scale convention 1 million requests per month. At first glance, reducing a prompt by a few dozen words may not seem like a big deal, but there's an important detail. A system prompt is usually sent with every single request. That means those extra words are not paid for once, they're paid for again and again every time a user interacts with your application. So if your prompt contains 38 unnecessary words, those 38 words are repeated 1 million times across 1 million requests. And that's exactly why prompt compression matters. A small reduction in prompt size may look insignificant on a single request, but at scale, it can save millions of tokens and significantly reduce your AI costs. Now, let's look at the impact at scale. Our verbose prompt uses about 65 input tokens per request, while the compressed version uses only about 14. That difference may seem small, but remember, the system prompt is sent with every API call. At 1 million requests per month, the verbose prompt consumes roughly 65 million input tokens, while the compressed version consumes only 14 million. That's a savings of more than 50 million tokens every month, without changing the actual task or output. This is exactly why prompt compression is such a powerful cost optimization technique. This slide shows 3 simple ways to reduce prompt size without changing what the model needs to do. The first technique is removing instructional fluff. Many prompts contain unnecessary words such as please, carefully, or in a thorough manner. These words consume tokens but rarely improve the quality of the response. By keeping instructions short and direct, we can reduce token usage while preserving the same meaning. The second technique is using structured formats instead of long sentences. Models understand bullet points, labels, and key value pairs very well. In many cases, a short structured prompt can communicate the same requirements as a full paragraph while using significantly fewer tokens. The third technique is compressing repeated context. This is often the largest optimization opportunity. If the same documents, policies, examples, or reference data are sent with every request, the token cost quickly becomes expensive at scale. Summarizing that information or retrieving only the relevant parts can save thousands of tokens per request. The key takeaway is that prompt compression is not just about shortening instructions. The biggest savings usually come from reducing repeated context while keeping only the information the model truly needs. Now, an important caution: compression isn't free. There's a trade off. If you compress too aggressively, you risk losing clarity, and the model may misunderstanding the task or produce worse output. That can cost you more than you saved, either in retries or in output quality. The goal isn't the shortest possible prompt, it's the most efficient prompt that still reliably gets the result you need. So there are 4 items to be checked before compression. Number 1, can I remove this word and still be understood? Number 2, can this sentence become a label or bullet? Number 3, is this context sent on every call, and does it need to be? Number 4, did I test the compressed version against the original for quality? Hello, this is a lab part. In this lab, we will show the difference between verbose prompt and compressed prompt. Here we use verbose prompt. This is a normal prompt, original prompt, we used to do to make sentiment analysis for the user review. For compressed prompt, also use a summarized version. For the verbose prompt, that's called uncompressed, but gives the same instructions and meaning for the model. Here I make function to make a count of tokens by giving him user message, feedback, and the system prompt. Here's the user message. Feedback is the user message sent, and also the system prompt to return the sentiment analysis result. So I make a call, using one time for verbose prompt, and the other time was compressed prompt. If we see the result, verbose system prompt counts 34 words. That's equivalent to 60 input token, and compressed prompt that count 8 words equivalent to 36 input tokens. So we have a reduction for 40% reduction in input tokens in this case. If we make from cost comparison an assumption for 1 million requests per month, and these input price, this we use with price of $3. So the comparison result we make, the verbose prompt for these input tokens that costs $180, and for compressed prompt, it cost $108. So we make a save around $72 per month. Here we make a checking for the quality of the model after using one time for verbose prompt and another time for compressed prompt. So when we run both, you see the result of the output. For verbose prompt output, also the result is the classification result was negative, and also for the compressed prompt, the result is negative. So our conclusion here, however we use compressed version for the prompt, we didn't get any negative impact or bad quality effect. We got it from the model after briefing or summary of the prompt. So we get the same result with defined less prompts and input tokens. This is a comparison for the token usage. For the input, we see we use 60 input tokens, and for compressed, we used 36. So we make a save in input tokens around 24, with a percentage of 40%, without any affecting on the model quality response. This is the idea of compression prompt. Trimming your prompts is powerful. But what about the data inside your prompts? Documents, knowledge bases, reference material. In the next episode, we tackle Layer 2's final technique, RAG, Retrieve Augmented Generation, where instead of stuffing everything into the prompt, we retrieve only what's relevant, on demand. See you in episode 9.